Hello, everyone. Looks like we're live now. Starting up the stream, just sending out my normal messages to people to let them know that we are live. So, office hours for intro to ABM, starting now. Okay, put it out there. Let's put it on the forums. And we should be good to go. Class announcements. Office hours for week 11. 11? It's week 11, right? Week 11 starting now. Did I get that right? I sent out an email about it last night. So, week 11. Yeah, week 11. Okay, so here we go. So, just wanting to check in a little bit and tell you guys what's going on. So, this is week 11. Unit 7 was posted late last week, and it's in completion. And Unit 8, the first half of which got posted late last night. The rest of it should be up in the next day or two, basically, with week 9 following shortly thereafter. Trying to get them out boom, 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 so that people can kind of go through and get all the videos up there, and they can kind of handle them when they want. So Unit 7 was about validation, or comparing your model to empirical data. Verification, comparing your implemented model to a conceptual model, right? Basically making sure that your model is operating correctly. And replication, which is replicating someone else's model, right? Chapter 8, or Unit 8, is actually, it's the first time we've deviated from the textbook somewhat in terms of the numberings, right? Unit 8 is going to actually be related to the appendix of the textbook, which is on the history of agent-based modeling. And it might seem kind of weird to do this now, this late in the course, but I personally believe, that the way to learn is to learn how to do things by doing it, actually trying to do it, then learn the theory about it, and then learn where it comes from. It's my personal belief about the way that makes the best sense, right? But in Unit 8, we're going to be going over some of the places that agent-based modeling grew out of. Now, agent-based modeling is huge, right? And it comes out of a lot of different fields, and there's whole areas we're not going to cover during this week, right? Such as individual-based modeling from ecology, right? Like, that's an area that has an entire sub-discipline in and of itself. I'm pretty much highlighting the areas that personally impacted my use of agent-based modeling quite a bit, and that I feel really led to software developments in agent-based modeling, substantial software developments in that space, right? It's somewhat a personal history. I'll give that caveat for sure. It's not meant to be this kind of objective statement about the fact that these are all you ever need to know about the history of ABM, right? So with that aside, I think it's a good little take. And the other nice thing about doing history this late in the course is that it actually gives me a chance to go back and revisit a bunch of classic models that we haven't had a chance to talk about for whatever reason at other points in the course, right? So for instance, we're going to talk about genetic algorithms a little bit. We're going to talk about the use of agent-based models for curriculum in education. We're going to talk a little bit about the game of life, and about 1D cellular automata as well, right? So this kind of gives us a chance to step back. Now, Unit 9 is going to be interesting, because Unit 9 is what we call advanced agent-based modeling, and that's equivalent to Chapter 8 in the textbook. However, I don't want to leave it just on what was written in the textbook. This is a video course that I can update on a regular basis. And so as a result, I'm going to try and put in some interesting agent-based modeling approaches that have developed recently that I think are really cool. Some of which we've kind of discussed a little bit in the talk before, but essentially some of these will essentially be mini scientific talks, right? They'll be my presentation of results that either probably myself, because I'm most familiar with my own work, but in some cases maybe other people's work that has been done recently, right? So kind of gives you an idea of what to expect, and that's it. Unit 9 is the last chapter, so if you have anything you'd really like to see covered or talked about in Unit 9, please let me know. I'll see what I can work in for sure. Okay, so that's it for the course material. Let's talk about deadlines. And just to remind, I posted a bunch of emails. I talked about this last week. But just to remind everyone, the model review assignments should be all wrapped up. The model document review assignments should all be all wrapped up. Because of all the little bugs we had with the peer review, apparently some people got comments back on models that they hadn't actually graded or hadn't actually submitted and things like that. Well, basically, we're working on trying to figure out solutions to these problems. Hopefully, they'll all be resolved in the next couple of days because we need them for the final project assignment. But because of all that, we've actually decreased the grade weight of the model document assignment to 0. What that essentially means is that it gets no weight in the overall course average. So any problems with the grades you got there will not affect your course grade and your course certificate, right? As I kind of try to warn you guys a little bit ahead of time that this is a beta attempt at peer review, and we're seeing what we can do with it. We're hoping that this next iteration will do better, right? Thanks for your patience and your understanding as we go forward with that. So that being said, the final assignment is going to be due on October 21st at midnight. So yeah, Pacific time, and that is your .n logo file that is the final project for the class. And once you turn that in, you then have 2 weeks to complete your peer reviews, and those will be due by November 5th. And November 5th will also be the cutoff date to complete the various exams. November 4th. Let me make sure I'm clear about that. November 4th at midnight will be the cutoff date to complete your exams for the course as well, right? So just because the content's going to stop being published sometime later this week or early next week does not mean you have to stop taking the test. The test you can take up until November 4th at midnight Pacific time, right? So, or 11:59 Pacific time, PM. So feel free to complete the test up until that day. At that point, of course, the course becomes closed. The materials will all be available, but that will be your last chance to get any assignments, any tests you need for the certificate, okay? And then we'll issue the certificate shortly thereafter, okay? So, anyway, so that's my brief announcements for the morning. If you have any questions about any of that, please let me know. Do see we have a couple of people on the Google chat, so say hi to Edward, Gustavo, Martin, Jim, Lon, Jerry, and Eugene, who just joined, right? And so, hello everybody. Feel free to go ahead and send in some, any questions you might have. I got a couple from the mailbag, so I'll go over there as well and check it out. Also looking to see if there's anything in the Twitter feed. By the way, I see several of you have started following the Twitter feed. Just so you know, I use the Twitter feed to repost any interesting agent-based modeling tweets I find. So there's a lot of retweets on there of things that I see, right? So if I see something in Twitter, in the Twitter sphere that looks interesting, I'll post it up on at Intro to ABM. So there's a lot of content up there that I'm not posting anywhere else, just so you know. So it gives you some incentive to follow the Twitter feed and kind of see what's going on there. There was so it does look like there was a question that came in. So Eugene asked, will the videos become unavailable after the course? No. The videos will remain in their current place for in perpetuity, essentially. If we relaunch the course, the videos might change and shift around, right? But these videos will always be accessible to you in their current form until that happens, at least, right? So you should be able to check out the videos at any time going forward. Okay, so let's see. There were one other question that came up in the forums I wanted to mention. There's a question about replication. So someone asked if it'd be okay to replicate a model for your final project rather than designing your own model. And yeah, I think that's a great idea. The one thing I would make sure is, just follow the standards I talk about in replication. Make sure you set up a replication standard, and then make sure you document in the info tab how the model either meets or does not meet the replication standard that you set up. Other than that, I think it's fine to do a replication. Also, I think you should, if you're doing the replication, you should of course revisit the questions of like, is the model appropriate, right? And so to that extent, as I said in the previous office hours, your grade, the rubric by which you will be graded for the final project, is whether or not your model meets the claims that you're describing in the info tab. So make sure that you've redocumented those claims if you're doing a replication, right? Other than that, I think those were most of the questions from the forum that have come through recently. Just double checking. There was a question: do we have until November 4th to submit end of unit tests? Yes, you do. That's fine. I just talked about that, and then there's a bunch of questions about the peer evaluation and stuff like that. So this is one discussion I wanted to bring up. Alberta had posted this about the questions about asynchronous versus parallel updating, and I want to make sure I address this at some point. So he makes the claim that it's very difficult to understand the relationship between asynchronous versus synchronous updating and sequential versus parallel updating. And I highly recommend you go check out his full forum post if you want. It's in Unit 6 on analyzing agent-based models. And so one thing I want to make sure is clear that I realized I didn't make abundantly clear during the lectures was that asynchronous versus synchronous and sequential versus parallel are all relative somewhat to a time step, right? So asynchronous means that updating can occur within the time step. In other words, an agent can see other agents' actions within a time step, right? Synchronous means they can't see until the time step has finished, right? Parallel versus sequential usually actually doesn't have to do necessarily with a time step. You could have the fact that but usually it's thought of in the context that all agents move parallelly within a time step, right? Now the reason why I say it doesn't have to is because you could have sequential could mean that each agent takes an action, that action is equivalent to one time step, right? And that's also considered sequential updating, right? But the big difference is there aren't any other agents taking actions at the same time that agent is taking action, right? It is, and Alberta makes a comment that if you dream up your model with parallel behavior, then reduce it to high granularity sequential behaviors, different sequences could yield different outcomes, but you don't want to do that. Because you wanted parallel behavior, right? And he's very right about that, right? So this is a tough one, right? The way that a lot of times parallel behavior is actually modeled is that instead of actually doing real parallel behavior, you try to make the actions as small as possible and then allow them to occur kind of in random sequential order, right? And that's in fact what the ask concurrent primitive, which is actually the original way the ask primitive worked, is trying to do. It's trying to break up your code automatically into the smallest possible units and then have them operate in sequential order, but with random execution, right? And so Alberto's right that, the sequencing, when you're doing it in sequential order, can affect the results. He's very right about that. And that's why Ask Concurrent actually enforces a randomness to the order, right? Because that forces you to kind of confront the fact that you don't know what order the agents are going to operate in when they're operating these decisions, right? But the problem is that also makes it very difficult to understand how this should work, right? In reality, if you really want to do parallel programming, you have to work on a parallel machine, right? Where you actually have different threads running separately from each other on different cores. So this happens, in a number of different ways. In computers, most computers are inherently sequential. You can use general processing graphic processing units, right? And those essentially can allow you to do parallel behaviors, right? But then you do have to think about things like if you have two sheep operating on different patches, right, and they eat grass at the same time, right? Or sorry, two sheep operating on the same patch and they try and eat the grass at the same time, who gets it? So you have to figure out a way to resolve those conflicts, right? And most of the modern day systems, the way they do is basically all the agents can submit resource requests simultaneously, and then there's some sort of centralized server that actually resolves those requests in some interesting way, right? And depending upon the severity of those requests, maybe that resolution happens immediately, or maybe it happens later on down the line. That's the basic idea for the difference between these different systems. I don't know if I helped clarify things or if I just muddied it more. The important concept I want you to take away from this is you need to think carefully about what your scheduler is doing, right? And whether you're using asynchronous versus synchronous scheduling, and whether you're using parallel versus sequential updating. You're going to be using sequential updating almost assuredly, and if you're using standard NetLogo. But think about that when making your decisions about how you're using and what those interpretations affect the model. Okay. So another couple questions came in on the feed. Edward asked, will you use Twitter to let us know when the next version of NetLogo is released? Most likely, I will just retweet the NetLogo announcement as soon as it comes out. I haven't seen it yet. I'm scanning through. I basically just use TweetDeck, and I keep a search feed on NetLogo. So assuming that the NetLogo Twitter feed posts it, I will post it there. I'll also post it if I happen to see it somewhere else as well. Anyway, so yes, definitely. Kathy Anderson then asks, I use the 3D NetLogo program for my project. I was a little awkward because wrapping cannot be disabled. Yeah, NetLogo 3D is quite a bit different than traditional NetLogo in many ways. I try to talk about a few of those differences when we are going through it in the course. But yeah, there is no ability to disable wrapping, mainly because that causes some problems with the way the graphics processor handles those particular calls. So I think it's actually an issue with, NetLogo 3D is actually implemented in a different visualization engine than the original NetLogo language. It's implemented, I believe, still using OpenGL, at least it was for a while. I'm happy to talk about so it's just a little bit different. Gustavo asked if that can be covered in the advanced section. It's already in chapter unit 5. If there's briefly, if there's additional discussion or questions people have, let me know. Let me know how you'd like me to cover it, basically, and I can see about working some of that in to the course. But Kathy, I will definitely let the developers know that that was an issue for you. If you could, a lot of times what they love to see is they love to see you actually documenting the use case for why you would want wrapping disabled or enabled. Sorry. Wrapping disabled. so if you can send, I highly recommend the NetLogo group is really good. They will respond to emails. So if you go to, I'm trying to remember the exact email address they like to have. It's not bugs for that one. It wouldn't be called bugs. It's a different one. Contact us. There we go. Okay. If you go to feedback@ccl.northwestern.edu, if you email feedback@ccl.northwestern.edu, that's a good place to send in any comments like that. But to make it a successful comment, you should talk not only about why you want it, but you should also present them a use case so they can look through it. Okay. Okay. A war game simulation. Awesome. Sounds cool. So send that to them and let them know. Okay. I'll mention it to them next time I talk to them too as well. So let's see. Let's go back to. I had a question that I've been promising for a while to get to, and I'm trying to pull it up because I actually made a note about it in Evernote. About GIS. Oh, from Gustavo. That's right. So Gustavo had some questions about GIS integration and how to best work with GIS integration in NetLogo. I will put together a couple of citations that I already have. I just got to get them up on, and I'll put a note to do this repost to the forum. So I'll repost the citations to the forum. So agent-based modeling in GIS is really kind of cool, actually, in some respects, right? Because, and I alluded to this, but I didn't have time to go into a lot of detail in Unit 5. So GIS, if you think about it, is a model of pattern, right? It's allowing you to pattern where spatial events are happening in a system, right, where they exist. Agent-based modeling is, by definition, a model of process, right? It models how things change, right? Interestingly enough, GIS isn't very good at modeling process because the representation of a large database that's organized by geospatial coordinates is not a process representation, right? It can do snapshots, right? It can do like here's what the world looked like on yesterday, here's what it looks like today, here's what it looks like tomorrow. But that's not a process, that's a discrete snapshot, right? Agent-based modeling, on the other hand, is a process, right? It can say, here's how this part of the world can change into this part of the world, right? And so I really believe the integration of ABM and GIS is extremely helpful. And in fact, I was involved for a long time with a project that was working on building tools that would allow people to combine agent-based modeling and GIS together into one simple environment. There is a GIS extension in NetLogo that will allow you to bring in things like Esri shapefiles and other data files directly into NetLogo. You can also then run your model on those files, and then you can output the results back. And the nice thing about that is that then you can do some fancy analysis in like an Esri product, ArcSoft product, right? You can analyze a lot of your data. You can then output that data to a shapefile, which is what Esri outputs as its data files. You can then read those shapefiles in NetLogo. So imagine, for instance, you're looking at like a good friend of mine, Moira Zellner, up at UIC does. You're looking at water use, right, in particular environments. So imagine you're looking at groundwater use in farming communities, right? And so you could, for instance, read in a bunch of data about elevation and about porous landscapes in farming communities in whatever your study area is. You can then simulate different policies as to how they might affect those landscapes, and then you could send the data back to the GIS data to see if you could to get a better understanding about how that affects the patterning of behavior in that system, right? In many ways that's what I'm interested. Now, there's another, and Gustavo asked last time a lot about So that's GIS at kind of the most macro level, right? At the level of what you're looking at, like land use patterning, right? There's also a use of what I would call actually less GIS and more spatial modeling, right? Where you're doing things like looking at the use of you're using agent-based modeling to simulate patterns of behavior through a space, right? And so people like Michael Batty and his colleagues at the Center for Advanced Spatial Analysis in England do some great work on this, right? So things like, and so does Paul Torrens, who's now at NYU, actually. And in those cases, you're looking at things like, if people are fleeing from a disaster, how do they move through the space, right? Or if people are coming in for an event like the Zozobra event that we talked about early on in the class, right? How do they move about in that space? And you know, Paul gets into some very sophisticated models of actually understanding human locomotion and using those models to simulate patterns of behavior in that space in very interesting ways, right? So that you can better understand how agents move around there, right? And there's some cool stuff that's being done in that, but that's, you know, some of that is GIS related in that it could use GIS data, right? But a lot of it's at a much lower level where they're actually using like floor plans from a building or something like that, right? So that's another case that of places where there's these differences or these uses of kind of what I would call spatial modeling and agent-based modeling. So I hope that helps. I feel like, I do feel like there's kind of this nice divide of spaces, right? I guess is what I'm trying to get at, where agent-based modeling can complement spatial modeling. One is kind of at a macro level, right? And that could be things like, trying to understand land water use. Or another example is people who look at retail location decision making. So if I have a model of traffic patterns in an urban area, can I decide where to build my next gas station, right? So that's kind of these macro level questions that GIS and ABM can work together on, because they can both you can use the GIS models of pattern along with the agent-based models of process to help each other. And then there's the more micro level analysis that it kind of looks at how you can understand the movement of individuals through space, right? And some of that uses quote unquote GIS data, but some of that's just using what I would call spatial data, right? Any examples of using ABM to analyze video crowd data is what Gustav was asking now. Yeah, so there have been, I don't know if I'm going to be able to cite anything off the top of my head, but yes, people often build their models from simulation data. I know Paul, for instance, has definitely done some of this, where he's videotaped people moving and then used those videotapes to influence the models of crowd movement that he's looking at, right? So Paul Torrens at NYU, formerly at UMD, formerly at Arizona State before that, would be a great person to look into to see some examples of using ABM to analyze video crowd data. I don't know any, I definitely have seen a couple other instances, but I'm not going to be able to give you any names off the top of my head. But yeah, so Paul often looks at this, like he actually runs like simulations, for instance, occasionally, or at least he uses other data from other simulations, but he gets, regardless, people bring people into a room and then they ask them to like exit the room as quickly as possible. And so then they videotape them and get the data from that. I don't know if anyone's actually looked at analyzing, for instance, real-time crowd panics or something like that. That would be interesting to look at as well. So hope that helps, Gustavo. Let me know if there's any other specific questions you have, and I'm happy to answer them. Okay. Let's see. Anything else coming through? I'm just looking through the feeds. I did have one other question in the mailbag. Just want to kind of double check the live feeds quickly to see if there's anything else coming up. Looks like that's about it. Okay. So let me Jerry is actually having some issues with his model, so I was gonna take a look at this. It's gonna try to open Netloogo 3D. Hold on one second. Okay, there we go. Got it open in Netloogo 2D. So let's see. Get rid of some of these windows. Okay. Window capture. Netloogo. And where's Netloogo? Okay, so here we go. Block myself out for a second. Okay. So Jerry is saying that I'm struggling with how to structure the Go procedure to keep other peoples from linking to students they are already linked to. Okay. So blow this code up a little bit. Let's go down to the Go procedure. Nope, I'm good. It's gonna make it too big for the screen for you guys. Okay. Make sure I'm staying on the screen. Okay, there we go. Decrease it a little bit. So if all the students have a belongingness less than 5, then stop. So that must mean that they feel belonging, and so therefore you can stop it. Ask the turtles move, and then have them ask one of the other turtles if any students in radius 5, and then their random flow, if they're probably asked where are you really from, create link to one of the students in the radius, right? And then ask the students, let the number of links be count minor links. Okay, so all looks good. So what's the question again? The question is, I'm struggling with how to structure attach to keep other people's from linking the students they already are linked to. Okay. I see what the problem is. So it's this procedure right here, right, where you're asking the students to create a link, and is it giving you errors when you do this? It's not actually giving you errors. It's just causing problems. Okay, so yeah, so this is a classic problem. Let me kind of talk about it in an abstract sense for a second. So the basic idea is that when you want to create a new link, you want to make sure you're not creating a link to someone you already have, right? Create a link to. And so let's see, what is other people set to, basically? Oh, so these are the people who aren't the NNI students. I got you. Okay. Non-native students. Okay. So ask one of the other people if there's any in the radius thing, create a link, right? But you're right. Right now, this code could create a link to a non-native student it's already has. So you're asking one of the other peoples if there are any non-native students in a radius of you. Then if random float 100 is less than probably ask where you're really from, create a link to one of the other students in that radius, right? So there's a couple of things here that I would change, right? One of them is that, sorry, I'm scrolling too fast. My new Mac is a little fast on that. So first thing I would do is I would, rather than doing this all in one statement, I would first try and figure out a target, much like, and this is just kind of standard practice, is that when you want to take an action with another agent, first identify and create a local variable for that agent, right? And the reason why you want to do that is because it makes it much easier to interact with that agent if you've now captured that local agent in some variable name, right? So I could say let friend, let's say target friend or potential friend be any NNI students in radius 5, right? Okay, so this is going to establish who the potential friend is. Now, I want to make sure that they're not someone I'm already linked to, right? So what we can do is there's two ways to approach this. So we're creating links too, is that correct? Right, creating link 2. So what we can do is we can say, we can ask if this potential friend is in the linked neighbors set. How do we want to do that? We want to say, no, we don't want to do this. We don't want to do anything. So let potential friends be NNI students in radius 5. That much is obvious. We now want to remove any of the friends from this set who are not who are already in my friendship connection, right? So what I can do is let's see. So I'm trying to think quickly how to do this the best way. So let friends I have be my be link neighbors, right? So that should all work. Let me just double check that. That's not going to cause any problems. Links is a directed breed, right? So it's well, I always forget the exact definition here. Hold on one second, I gotta look it up. So it's link neighbors when it's undirected. When it is directed, it is called outlink neighbors. Yes, so you're creating it to it, right? So the friends I have is the outlink neighbors. So I want to basically subtract the potential friends from the friends I have, and there actually is an easy way to do this. There's an agent set command, if I remember correctly. So no, I suggested at one point that we should do a differences command. I don't think it actually ever made into the language. Yeah. I don't think you can do. What you'd love to be able to do is let potential friends, so you could call this, names. Let target friends be potential friends minus friends I have, right? If agent sets work the way I would like them to work, right, this should work. Let's see if it does. I mean, I doubt it, but yeah, because minus an expected number. Okay, so what that would do is it would take the list of all potential friends and remove any who are in the other list. So what you want to do instead, I think, is calculate friends I have first, and then you're going to return the set where these ones are not members of that other set. So you can grab this as a set and say with, because that'll give you a subset, not member. Let's see, let me check member. Member takes an agent and agent set. That's not going to work because we need a recorder that runs on the self itself. If not member self, friends I have. This should work. Okay, so right, yeah. Okay, so let's double check this. Print friends I have. Print NNI students in radius 5. print potential friends. And I often do this just to debug my own code, so I'm basically just having it print out every step along the way to take a look, and then I usually put little asterisks around it just so I know where that debugging code is starting and stopping. And you can get more detailed with your notations if you want, right? But see, right now, saying it's one turtle, 0 turtles. So I think it's working because it's because I'm printing out the agent set, so I could print out who of, and this will actually print out the lists instead of printing out just the fact that it's an agent set. Right. Okay. So So this will print out the who numbers for those various calls that I'm doing. And so the first number is going to be the list of friends I have. The second number is going to be the who numbers of the students who are in, the non-native students who are in a radius 5. And then this last one is going to be the potential friends, which is the students who are not a member of the friends I have, right? So that's what this code is doing. It's saying find all the students in radius 5 and then print out only those who are not a member of the friends I have already, right? So it's a little kind of piece of code that kind of does this. It'd be nice, essentially this is doing a set difference, right? So you can see that in this case, for instance, if you remember back, the person has no friends. There is a non-native, number 8 within 5, and so that is a potential target, right? And let's see if we can find one. Right, so in this case, right, the individual has 2 linked neighbors, 3 and 0. Those are also the people who are non-native nearby, and so it reports that there is no one who is a potential friend nearby. I guess it's new potential friends, right? And in this case, it's great. So this says it's working perfectly, right? In this case, it identifies a friend that you already have, which is 4. It identifies that 4 and 7 are nearby, but it says that only 7 is a potential friend. So I now have pretty good confidence my code is working. Often I won't actually delete my debugging code. I will instead comment it out, right? So now I've done this, but I haven't actually created the link that we need. So now I can rewrite Jerry's code to say if any potential friends, then if random float 100 is less than this variable, probably ask where you're really from. Then you're going to create a link to one of those friends, right? Create link to one of those friends. One of potential friends. Right. And that should work. One other small change you could do to make this a little even more kind of this robust, choose a target first. So now we have a group of potential friends. I could say let target friend be one of potential friends, right? So actually, I could do it in here. Let target friend be one of potential friends, and then create a link to target friend. Now in this case, it doesn't matter too much because I'm only doing the one thing with that person. I'm only creating a link to them. But in the case where I want to do other interactions with them later on, right, I might want to create that local variable just so I have it around. And the reason why I'm doing it in here is because it's after this if any potential friends, so I don't have to worry about the fact that this could be the empty set. Okay? So hopefully that's helpful. Check on the dashboard. Yeah. So Jerry says yes. So I'll take that as good. Jerry, I'll send you a copy of this code, and I'll ask your permission to post it on the forum as well if you want, just so people can see what we did. But other than that, looks pretty good. Okay. Kathy has another question in the meantime. She says, she's actually providing a potential solution. Great. So create a list of numbers, run a for each loop, use, this is a question. Create a list of numbers, run a for each loop, use n mod m to go through elements in the list so target can be identified for each loop. For each num list, ask turtle, let new friend, question +2, mod 10, create link with turtle new friend. I'm a little confused, Kathy, I gotta admit, I don't quite understand. Oh, you as a suggestion, okay. Yeah, so this, it seems like you're creating a solution that would create links to a bunch of different turtles, right? So you have these different networks of suggestions. I like that idea. That's actually very similar. Let me actually pull up a model that does something similar to that for you. Let me save off Jerry's code real quick so I have it. Let's see. So if you go into networks, right, so you know who is linking to home, right. So if you go into networks and you go into small worlds, the wire procedure does something similar, right, to what you're suggesting, Kathy. So I'm just showing this so that everyone can see it, because it's not in the Google chat window, right? So to wire them, you let n be 0. While n is less than the count of turtles, you run this command, make edge between turtle n and turtle n plus 1 mod the count of turtles, right? And so what this does is create, so let's think about this. So if this is turtle 0, then this creates a link to turtle 1, assuming that there's more than one turtle, right? And if it's turtle 2, it creates a link, and so forth and so forth. And what this winds up doing is creating a lattice structure on the network. So if you hit setup, right, you can't really see it. Actually, you can see it if I highlight it. But this node is connected to the two nodes on either side. This node is connected to and so forth, right? And the reason why they did it in this particular way is because this little mod at the end means that it's going to link back to the beginning, so you're going to get a circle rather than a straight line where everyone's connected to everyone else, right? So it's very similar to kind of the suggestion you're making of having this list and counting to the list. Very creative solution, Kathy, for sure. So I did it with agent sets as opposed to lists, but it's similar in some cases, right? Yeah. Okay, so I think, let me see if there's any other questions that have popped up in the mailbag. I think that I'm going to actually respond to Josh Hoover sent me an interesting model where he's looking at potentially trying to understand potential biases in police shootings of civilians. And so I'm going to have a conversation with him, but I might take a look at that one next week if it looks interesting. It looks very interesting. I don't mean to say that, but if we can come up with some way to actually demonstrate some of the NetLogo features or agent-based modeling features out of it, right? Other than that, I think that's it I have for today. We're just about on time, so it's not no reason to kind of pull it out. Gustavo asked me if I could have a colleague interview me about research and talk about including my ideas on the future of the field. I don't know if I have a colleague who's willing to do that, but I will definitely include a talk in chapter 8, unit 8 on, unit 9 on on that topic. Oh, I just realized I'm still on the NetLogo window. Hold on. Okay. So I'll definitely include in Unit 9, I will definitely include a section on my thoughts on the future of agent-based modeling and research in the field. So that will definitely be in there. I don't know if there's someone else who would do that for me. Integrating AI with ABMs. Well, that's actually, in many ways, we talk a little bit about that in Unit 7, right? Because when I'm talking about using machine learning in ABMs, I'm talking about that. Now, we talked about it from the perspective of applying machine learning to the top of an agent-based model rather than inside the agent-based model. But I will definitely talk about the relationship between machine learning and ABM in chapter in Unit 9. Definitely some interest in the police project. Like I said, let me talk. I hadn't actually had a chance to talk to Josh about that ahead of time, so I'll look at that. Are there any software packages to analyze spatial data, or is that statistical and mathematical? Yeah, Gustavo. The best package. I mean, the packages out there are Esri packages are probably the state of the art. Things like ArcSoft products you might have heard of, and so those are out there. They're not free; they're very expensive. There is an open source GIS package called Grass GIS, which is getting some traction and doing pretty well. And if I remember correctly, some of the earliest NetLogo GIS implementations actually use Grass rather than Esri files. So that's a great suggestion to take a look at that for sure. Any suggested code to have agents wait for a number of ticks at a time? And there's a discussion about the fact that the wait command is only for time, not ticks. Yes, that is correct. So wait actually is one of the few things that actually is outside the model, right? Because I can say wait 3 seconds, right? And it'll wait for 3 seconds. And that definitely happens it. Within the code, right? What I recommend doing, let me actually, I'll pull this up real quick. It's something you can do pretty easily. All right, so I'll bring up the window, file new, right, okay. So if I have my model here, right, what I can do is I can say turtle's own activation time, right? And I can say to set up, clear all, reset ticks, and to go, and right, okay. And so I can say create 100, set activation time, random 100, right, okay. And then let's actually do a couple other things. Let's just do set color red, set X, Y, random X coordinate, random Y coordinate. Right, okay, and now I can say if activation time mod 100 equals ticks, ask turtles, because I need to know the turtles first. If activation time mod 100 equals ticks, forward random 5, right random 90, left random 90, right? And so what this is going to do, let's see if it works. Sorry, too much writing, switching back and forth between different languages. Okay, let's see if I did this right. So we can add a button for setup, add a button for go. Stop moving. What did I do wrong? Mod. If ticks, I did it backwards. If ticks, mod 100 equals activation time. Now it looks like they're all moving constantly, right? But if you slow it down and you hit speed it up for the setup, slow it down again, and now hit go, what you'll notice, and that's actually too fast even at that level. All right. What you'll notice is that only a turtle or two is moving every tick, right? And so what this code is doing, and I'll post this up on the forums, right, is it's setting an activation time for each of the turtles to a random number between 0 and 100. And then it's taking the tick counter, which is in the variable ticks, dividing that by 100, and whatever the remainder of that division is so if it's 5, right? If it's the 5th tick, mod 100 is 5. If it's 105th tick, it's also 5. And so if those two numbers, if that remainder is the activation time, then that turtle will activate at that time and it'll execute the following code, right? So this is some quick code to kind of activate the turtles on a specific number of ticks. Oh, you want to see pen down? Yeah, it would be kind of nice to see it, right? So pen down. Okay, so now let's do setup and go, right? That's still too fast. My machine's a little too fast, sorry. Gotta make it really slow. Okay, so now you can see that only a couple of the turtles are moving each tick, right? As it goes forward. Okay, yeah, great suggestion, Gabby. That definitely helps. So I hope that's helpful and kind of gives you some ideas. And like I said, I will definitely post this code up as well. Is that kind of what you were looking for, Jim, in terms of answering the questions? So, okay. So I saved it off. So I think that's it. All I have for today. I don't think I kind of went through all those questions. And if you have any more, shoot me an email and let me know. We've got, so, you know, we've only got, of these great little chats, we've only got next week, the week after, and the week after that. So 3 more of the office hours before the course is over. Okay? So thanks, everyone. Take care. Bye.